All right, welcome back, generals, to another Let's Fix the Generals 0 Hour. In the last video, what did we do? We compiled a thyme ng. I don't know what ng stands for. Ng, I don't know. New generation. Maybe we can inquire. So the goal of thyme ng is to compile against Visual Studio 6, which is a very old compiler from Microsoft that was actually used for the original game. And the goal would be to try to really have one-to-one copy of the code and generate it with the same compiler, so we get the same assembly output as the original compilation of the game. And then we binary compare our compilation with the original and see if there are mismatches, right? That's a goal here. Okay, so we have compiled it successfully. Let's take so we build it here with a PDB file, right? So how about we take those two things and we copy it here into our debug folder here. And I don't know why there's a thread protection pop-up. So the hope is now that we can somehow use this PDB and the executable to generate assembler that is similar to what we get, or identical to what we get from game.dat, right? Okay, so the hope currently is that we use the PDBDumper. Let's make open this here. What does he say here? So PDBDumper from 5 years ago. Yeah. PDBDumper. Please refer to sample to dump. Okay, so I think the first step we fork this. Yeah, copy the master branch. Yeah, create fork. I will be back right away. Okay, I'm back. Okay, so we have created a fork. Then let's do a yeah, copy this. Then let's do start clone repository. Strictly speaking, strictly speaking, it's not part of the assembly armada, but let's drop it in there anyway. Okay. PDBDumper. Yeah. Clone. Okay, so the PDBDumper, it has a solution inside. Yeah. Okay, before we do any editing or integration into unassemblies, let's first run this thing. So this one, what Visual Studio version is this? Can we open it? 14. Visual Studio 14. What is this? Visual Studio 14. Okay, 14. It's Visual Studio 15. Okay, 2015. I don't have this installed. Do we need it? Can I perhaps just open it in the newest? Let's see. Open with the newest. Let's try to upgrade it. Because why work with old Visual Studio? Okay, we need to see if it compiles. Yeah. Let's see what happened in the project files now. Nothing. Okay. Okay, let's just compile it. Okay, it succeeded. Yeah. I created an executable. Nice. Okay. Okay, we got some warnings here. Let's fix those things. B, unreferenced local variable. What the hell is that? A. Let's look at our commit history. My changes. Okay, so Thompson's has added a bunch of changes here. Dump all specific dwords. He downgraded the version. Okay. Okay, so you added a bunch of code here. Yeah. Okay. Then let's just move this B in here. And then we also fix this. This one should probably be ZU. Yeah, and this as well. Oh boy, formatting was changed. Holy shit. Okay, that's not good. That's not good at all. Let's revert this. Then we also need to revert this. Tools. There's a README. Oh. Can we disable formatting? Formatting. Let's search for disable, well, Visual Studio, disable code formatting for project. Okay, that doesn't help. Basic, advanced, tools, options, advanced, Pretty listing. Code style. I don't know why it applies it to this project when I didn't explicitly told it to do so. It's a bit upsetting. Power commands. Formats. Documents. On save. Yeah, I don't know how to turn this off. Oh, I hate this stuff. Why can't it be easy? Always has to be complicated. Clang formats. My gosh, that music is horrendous. How to turn off formatting? I don't get it. Format on save. Format on save. Nothing. It's fucking annoying. Can we Clang format file disable format? Can we... Okay, maybe this will work. Folder, no, not folder. New text document, clang format, ignore. Edit, and just put a star in there. Let's see, maybe that works. Cancel. No, does not. It's unfortunate. Okay, let's try this. Dot clang minus format, edit, disable format. Never. Aha. Okay, at least it picks it up. That's good. So sort includes invalid arguments. How about false? Also invalid. Let's delete this. Invalid boolean, huh? Okay, what's the expected format? Clang format here. Oh, that looks much different. Okay, this looks like a YAML format, something like that. Okay, disable format, true. How about that? Will this work? Let's see. Oh, it works. Thank God. Good, so we got that sorted. Okay, let's recompile, rebuild. Okay, let's move this B down here. And here, ZU, ZU. Yeah. There we go. Oh boy. What is this? Huh? Where does this suddenly come from? Okay, I'm curious, like before I compiled with warnings and now this. Why? Okay, that's wild. So the problem I'm seeing here is WMain doesn't know this function. So what if I put this up here? Void, yeah, just declare it. Does that work? Yeah. Okay, but that makes me wonder why is this not already declared here. Jesus. Oof. Ah, DIA2Dump H. There's a header. Okay. And it's included here. But the case is wrong. Why? Why is this erroring? I don't understand. Identifier not found. Okay, I'm so confused right now. Okay, let's remove this file. Save the format. Let's sort includes. Sort includes never. Let's see if that saves. No. It expects Boolean false. Okay. Okay, maybe that's why it fails, because it sorted includes and then it fails. That could be. Yeah. Okay, that's very likely. Okay, let's revert all this garbage here. And this garbage. Bool B. Yeah, let's try compile it. Okay. Good. Okay, ulong. Okay, then how about ul? Okay. Good, so we fixed the warnings and everything. Let's see if everything is looking good now. Yeah. Okay, then let's make a commit here. Actually, let's create a new branch. Create branch. The question is, do we want my changes from Thompson's? Some wild code here. W main 2. What is that? Let me ask here at Thompson's, do we care for my changes in PDBDumper? My changes, commit. My changes. Or do we need the my changes commit for PDBDumper? It's not clear to me, as I didn't study it. But okay, for now, how about we create a new branch? Let's call it cleanup. I don't know. Or I don't know. Yeah, cleanup, whatever. Can rename it later. Okay, so first commit is just disable Clang format and fix warnings. Okay, that's it. Good. So it compiles, and that's all we know for now. Then next, good. What do we do? I think we just want to test it, right? So let's go to here, the main function, which is at the very top, right? It's a huge file. Holy shit. 3,000 lines of code, yeah. Sorry. So there is... Is there a help for this? Print help options. Okay, how about we open... Actually, we can just open this. Aha. Okay, there we got some, yeah. So... print all the publics, globals, types. Okay, so we just exe and then file name. Yeah. And then what? File name. PDBDumper. Dump debug streams. Dump print symbols. Yeah. Okay, how about we simply invoke it as debugging. We working directory. Yeah. So we invoke it as -s to print, what was it? Print symbols. Yeah, print symbols. See what it does, and then we give it the where's it? Projects assembly armada, unassembly solution, debug. We give it, actually, let's go right to thyme folder. Thyme build here. And we put here this and thyme.pdb, maybe. Apply. Okay, let's see what it does. Okay. Can we get a... and the main function. Let's put a breakpoint here. Not load data from PDB. Okay. I think Psychana had the same problem, and he said, what did he say? He said registering the DLL. Okay. Let's put a note here. Man, read me. Must register MSDR DLL. I think I saw this being documented here somewhere as well. Here, register com server. Okay, we already have an admin command prompt, so let's put that in there. Succeeded. Okay, thank you. Then let's see this again. Yeah, let's go in here. Okay. Yeah. Yeah. Yeah, okay, this time it succeeds. Okay. Okay, so it does something. Clean up. Okay. Then how about... I think we need to invoke it as... Here. Properties. Then let's do DIA2Dump.txt. Yeah. Okay, let's hope it writes out there. Actually, I think I wrote that incorrectly. I think it's just one. I'm not sure. Let's see. Yeah, there's a dump. Yeah, it wrote in it. Okay, that's good. By the way, we have a lot of files open here. Let's close to get this clean again. It's always bad to have so many open files. Oh, yeah, now Notepad is dying because we clicked here on this. Okay, so we have a dump. Yeah. Main CPP. Okay, that's good. We get an object, compile, and now we got symbols in there. And we got a function here. Okay, this is nice. Yeah. Okay, so this tool in principle is able to read the stuff. Yeah. Okay. Good. Let's call this thyme ng.dump, or let's call it symbols. PDBDumper certainly can read thyme ng PDB. PDB can read thyme ng PDB. This is DIA2Dumper minus s thyme.pdb. Okay, well, this is already good news. So it means the code that we have here in the sample is able to read the PDB from Visual Studio 6 and print data for it. Okay, then next step, we need to think about how we can use it. I don't think we need this whole tool. We just need to copy bits and pieces to dump our own, to extract our own info, right? Load data from PDB. Let's do another with all to see what's all in there. That's a good idea. So we do minus all. Let's dump it in all. Let's call it thyme ng all. Okay, let's run this. Okay, that was fast. Yeah, it's big. Okay, let's see what's in here. Modules, publics. There's a lot of empty lines here. Okay. Unicode string. Let's copy this here as well. Collapse. So dump all. Okay, let's look a little bit here through this file to see what's in there. Yeah. Okay, so at the top we have CMake files, we don't care. This I don't think we care. Public symbol, I don't know. This seems to be just a list of all symbols. I don't know. Okay. Symbols. Module main CPP. Pentium 2. That's good old times. Yeah, there's some data. Okay, a bunch of type defs, yeah. Okay. So basically we need to figure out what kind of information we can extract for our purposes, right? Okay, there is something here. Okay, so there is function. I don't know about the static thing. There's a length for the function. And I don't know what this is. Function debug start. Okay, I'm not sure if this gives us any info on where a function starts or ends. It's not clear to me. Function debug start. Debug start, debug end. Debug start. I don't know. Could be just for like in Visual Studio where you debug. I don't know. Okay. Some more data here. Okay. Okay, it seems to be just this data for all sorts of functions. Kernel 32. Huh. Okay. Also has some info about the imports from other libraries. Yeah. There's some. There's some information like which function exactly it expects. Okay, what do we got here? Globals. We would have to look up what these numbers here mean. I guess in code we can see it. Right now it's not entirely clear, but it's probably some offsets for maybe for the executable, maybe for the CPP. I don't know. I have to look it up. Okay, I'm not sure why it's now listing those. It's probably maybe I think it's possible that different, like this is like a high section of information, and there's probably some overlap of information, right? So globals probably show something that we have seen already before here, but just in different way of visualization. That could be, right? Data, types. Yeah, it gives us different visualizations. Yeah. Function. So it's just function names and whether they are public or protected or private. Yeah. vtables. Okay. It's constant as well. Enums. Yeah. Constant. It would be nice to have a PDB for original game. Yeah. That would give us a lot of metadata to work with. Yeah. But actually there is metadata in simple data in the. So we do have some simple data. This kind of data we have for the Mac binary of 0 hour. Yeah. It's not a PDB, but it's a Mac format. Okay. Okay, so I suspect that we will then group our assemblies by these object files here, right? So we will create main.cpp or main.s, right? Weapon.s for both thyme and for game dots. Yeah. So we do thyme.main.s and then game.dots.main.s. Yeah. And then these ideally would contain the same kind of things. Yeah. So we know from this weapon CPP compilant. It's CMake file. Yeah, okay. Lines. Huh? What is that? Okay. I have no idea what this is. I will leave you with that for a moment. I will be right back. Yeah. All right, we are back. Good. Let's keep on looking. I don't know what these lines. What this is? Line 15. What? Why? What? Ah. Could it be that this refers to assembly code? So line 15, huh? But then I don't know what this is here. Line 15 add. Yeah, we would have to look into code, like what these numbers mean. But like a mapping from CPP code to the actual assembly code. So you have a line, it has this length. Let's open main CPP. So we go to thyme ng, source, main CPP, yeah? And we see line 15. Here, line 15, len 16. Is that true? It's not character length. Maybe it's byte size, like this critical section. Can we see? Can we? Visual Studio 2022. Let's open thyme. Can we see a critical section? Well, I don't know what this critical section refers to. Let's search for a critical section here. Class critical section. Okay. So this contains this critical section here. And that is what? This here. It's 24 bytes. Okay, then, but then I don't know what this is. Because this is, wait. Hex 16. It's 22. Okay, let's look in code later what this is. I have no clue. Okay. Yeah. Line 15. Yeah. But it's cool because, like, if we get like a mapping from from assembler to CPP code, then it would allow us, if we have like assembler mismatch, to say, okay, what does this assembler refer to in the CPP, you know? So that if you get a mismatch, you don't just get to see like, okay, what's the mismatch in assembler, but what line does this refer to in the CPP? So this mapping would be really nice, I think. Yeah. And my understanding is that this is this, but I don't know how to read this yet. Yeah. Okay, so that is for this. Then we get to the white space. And here we get some more, what is this? Section contribution. Okay, there's a bunch more symbols. Yeah. I think it's good that thyme ng is not that large yet. So this means we have a relatively small file here to look at for starters. Yeah. Okay, I don't know what this thing is. That looks weird. Some binary table. Debug streams. I don't know. Injected FPO OEM. Okay. Good. But there seems to be we have stuff to work with. Yeah. So I think this one here, this one module, this is what we are interested in. Yeah. We iterate through the modules main CPP object, and that contains types and functions. Okay, how about we look for this function? Let's look for this string here. Let's see if we can find that. No? Then let's search for this one here. Print location. Okay, so this is print symbol. Print a symbol, name, type, etc. DIA symbol. Okay, let's take a look at this DIA symbol. What's in there? DIA interface. Huh? Ah, there is a DIA SDK. Interesting. I don't know why this is. Oh, how big is this file? 30,000 lines of code in a header. No way. Holy shit. This is outrageous. What is this library? Oh, it's generated. Wow. It's outrageous. Okay. I don't quite understand the P symbol. Why do I interface? Well, that's not helping much here. Maybe I need to put a breakpoint to see what is this. Let's put a breakpoint here. P symbol. E unknown. Oh my gosh. That's not nice. How do we interact with this thing? P symbol, get type, So that does have functions. Oh boy. Address offset. Get length. Get offset, get length. Yeah. Okay, so perhaps we get like good information from this thing. Yeah. Yeah. Okay, good. Okay, let's see. Let's try to make sense of these. Oh, it started writing. Let's let it run through. Yeah. Let's create a copy of this thing. Or let's change here our output to thyme ng txt. Yeah. Okay, so we are interested in learning what these numbers here mean, right? Print location. Let's see. What does this do? Oof. Okay. Static is relative virtual address. Address section, address offset. Print location. Okay, how about we put a breakpoint here? And then log is static. Which symbol is it? Do we have a name? Print symbol type. Get type. Jeez. Print name. Get name. Wow. Okay, it's undecorated name. Okay, it looks like there's really a lot of functions with this thing. Yeah. Okay, so we certainly enter in the static thingy. Do we also enter here? Well, let's put some more breakpoints here. Constant, let's see. Okay, and registered, register ID. Okay, no idea. We have a regrel, register ID. Let's see what it is. Print name. Flags. instance. Okay, so these are some kind of variables. Register relative, maybe. I don't know what the meaning is. Let's see. Is regrel. Location type. Okay. Register. Is register relative? Maybe that relative. Yeah, I don't know. Okay, let's take this away. Is this rel? This pointer? Let's see. M handle. Ah, M handle, yeah, it's class member. Okay. So class members are this. Is this rel? Okay. Constant. That is probably macros and stuff like that, and numbers, I guess. Yeah. Let's see. Print name. It's a macro, yeah. Okay. Okay. That's it. Okay. So we have constants, we have class members, we have registers, I guess in like functions and stuff, variables, and we have static, which is functions. Then I guess this can also be functions, I suspect. Or maybe not. Maybe that also counts as static. Okay, so here we have static, that is %s. Let me see. Ah, okay. Yeah, so we have static. Actually, that's a good idea. Let's search for these things to get an overview here. So the statics are like these function thingies. Let's see regrel. What do we have here? It's not found. This rel. Okay, also not found. N registered. Bit fields. Not found. Slot. Constant. Okay, that is found, yeah. We have seen this in debugger, yeah. Okay, data. Okay, so function debug start. Let's get back to here. Okay, so the first number is relative virtual address. Relative virtual address. Address section. Address section. And this is address offset. Relative virtual address. Relative. Yeah. I don't understand what this address section and address offset is supposed to mean. Relative virtual address, I assume that this is what it says, relative virtual address, beginning at that one section. But then I don't understand. So address section is just a number, 1. It's always the same. Let's search for this. It's always 1. It's always 1. Okay. Okay, so, but the way I understand, we have this DIA symbol, and this allows us to get various information through these various getter functions here, which there are a lot, a lot, infinite amount of functions. Yeah. Okay. So there's plenty to query. Okay, that's good. Get location type. Yeah. Must be a symbol. I'm curious about all these type errors. Is this written by... Was this written by Thompson's, or is this original Microsoft code? Text not found. Print symbol. Text not found. Okay, so basically Thompson's added a lot more functionality to display more things, right? Yeah. Okay, but all these type errors, that's original, by the original author. Okay, like here they butchered this word and this word. Yeah. And this word. Okay, yeah. So this symbol, how is this retrieved? Let's see. WMA load data dump all PDB dump load data from PDB. Load data from PDB. Search path. So I guess like this code is responsible for loading. No. Okay. So you just load it like this, and then you have a result and what? Huh. Aha. It returns some pointers here. PP source, PP session, and PP global. Okay. And then you use these things to query, basically, and then you just do cleanup. Okay, that looks simple enough, I would say. Yeah, so we just need to replicate this function and then the cleanup function. What is in there? Yeah, and uninitialize and some releases. Okay, simple enough. And then basically we need to write our own code to extract the info that we want. Yeah. Okay. Okay, I have a general idea of where we go with this. We don't use this tool here on its own, because this tool is catered to dumping like a lot of data. What we do is we just borrow pieces to put together what we would like to do specifically for unassemblies, but we don't like use this actual stuff as is, right? Yeah, and then we need to find all the right data in the various DIA interfaces and query things. We need to figure out what we want to query. Yeah. Okay, so that is the next goal. We need to figure out how to build the data that we want. Yeah. We can either try to do this before from this, or we do it as we go and implement it in unassemblies, or a mix thereof. Yeah. Let's look a little bit around more to get more comfortable. At least to understand like what is happening here. So this is symbols. Dump all symbols. Yeah, let's look in this one. Okay. Enum symbols. Okay. Find children. Piece symbols. Okay, and then you iterate it here. Okay. Find all the symbols. Yeah. Print symbol release. Okay. Piece symbol release. Yeah. Retrieve the name of the module. Get name. Compilant. So that is this thing here, right? No? Module here. Yeah. Okay. So we get the module here already. Okay, so I think this is a good starting point. The dump all symbols. This is a good starting point. So we have information about the module. We have information about the function eventually. Let's go to print symbol. Yeah. So here, sim tag data print. Where's function here? Print location. There's another children here. Print symbol, yeah. Print location. Okay. I don't understand where this function is coming from. Probably, how about man? Okay, how about we put a breakpoint here? And we just follow the flow a little bit to see what's going on. Good. So we have a compilant get name. Yeah. So that's the main.cpp. Good. And then it appends it here. Find children. Yeah. Print symbol. Good. So we have a sim tag, which is number 4. Sim tag function is not a function. Print sim tag. Okay. Indent. Compilant. Piece similar. Okay, so there's like a symbol ID. And by this we know what it is. Print compilant env. Print name. Okay, what happens then? Aha, then there's next symbol. Okay, what's the next then? Compilant details. Aha, so it's basically it just iterates through these enum children, and that gives us all sorts of info, and we just inspect what we would like to look at. Yeah. Okay, what's the next thing? 7. tag data. Aha. There we get into some actual data. Print location. We can actually also maybe open this thyme ng. I don't know if it's dumping right as it writes. Maybe not. It's not flushing in all lines, right? Yeah. Print symbol type. Print type. Oh, it's quite complicated here. Get name. Boah. So we are right here at the top. It's writing this here right now, right? If I'm not mistaken. S18. Yeah, it's writing this line right now. Yeah. Yeah, I still don't quite understand what this data exactly is here. But okay, this looks to me like it's like data page. It's like integer, 4 bytes here, bunch of types. too bad that we cannot inspect this. Oh, what is this here? Function info. Interesting. It's a tag function. Okay, so I think the first goal will be that in unassemblize we get to this point that we basically iterate through all these symbols, and that we would be able to inspect a function. So that we have this symbol, and then we would figure out, okay, what do we need to get from this function? Like, what address, what can we get, address, and so on. And then when we have that, then we could try to extract the assembler code from thyme.exe that these functions refer to, right? And then we see what we do with it. Yeah. Okay, I have like a general plan on how to start, but we need to look at a lot of the sample code to put together the pieces. Now there's also the question, so there was this effort by OmniBlade. Actually, we can probably see it here. Let's go to unassemblize. Here, PDB support. Let's check out this branch. So here, dump to config, PDB. What is this doing? Dump symbols, say symbols, read here, loads. Okay, this is trying to dump things, but I don't think we want to do it this way. We don't want to dump. We want to go through the PDB and try to extract the assembler code and try to generate the same output. So I don't know what the goal here was. Dump information about the symbols. No, it's maybe the goal here was to okay, maybe the goal was to write out a config file for for thyme.exe that is then just loaded back the same way that it's currently loaded here for so assembly armada, unassemblize, here debug. So right now it's using this config.json, right? Here. And that we basically create the same kind of config here. Yeah. The same, we export the same config for thyme.exe. And then this will be just loaded back and then generate the same output. Yeah, this could be working. Yeah. Okay. Yeah, we could do that. game dot yeah. Okay, how about we create a copy of this config and call this game.config.json, so that there's no ambiguity. And then basically we want to write out a thyme.exe.config.json, right? So, and basically we give it the PDB, and then we say dump symbols, this command in unassemblize, and then if it recognizes that it's a PDB file, then it goes through the PDB code to extract it. Otherwise it looks at game.dat to generate it as much as it can. Okay, it kind of makes sense to have generate a config, because then it allows us to generate the same kind of data first that can be but wait, no, actually, yeah, that's fine. Yeah, so basically the data that we put in config JSON, right, it's just a simplification, right? Like in the PDB there is so much more data, but this is just a simplification. So it's like a pre-processing step of transforming data and simplify it into our config JSON, make it simple. And then from there, yeah, and then once we have that, then we can test, okay, can it now generate the same kind of output? Yeah, okay. I think that's a good idea. So our goal will be to have the tool load the PDB and just generate this kind of symbols for the PDB thyme.exe. I don't know yet about the function names here. They're probably different kind of names. So perhaps we need to expand this and offer different kind of names here. This name is a little bit, I don't know if it will match this name exactly, probably not. Like when we look at, well, we can, let's look at some names. How about that? So we have this. So for example, we have, let's scroll here somewhere. Memory pool factory. Yeah, memory pool factory. Then we have this. Find. Okay. We have, let's search for all. Okay. Those are action, state machine, magic, enum. Okay, that's the enumeration. Pool init rec. Pool init rec. And the current data in here is kind of limited, right? It doesn't have fields for linking to CPP files and stuff like this. So we probably Need to expand. We need more data actually. Yeah. Okay, so memory pool factory. What do we have here? Do we have this here? Pool. Aha, look at this. Here we have something. Public symbol. Okay, let's search for this one here. Aha. Okay, so this public symbol actually does show up here as well. The exact same. Okay, so it should be possible to export the same name here. My suggestion would be to not just export this name, but to export all sorts of names. So this one is a public symbol, so we call it public name or something like this. And then we do, let's see, memory pool dynamic. Okay, so this, here, so this is a correct, this is another name for it, this init. Let's search for this. Yeah. Yeah. Yeah, I would suggest we make two names. This public name, and then we also put this name here. Like, which also serves a little bit like a documentation purpose and to like verify, okay, it actually refers to this. Yeah. Okay. Yeah. Okay, but this is already looking really promising just by the data we are seeing here. Let's close this. Yeah, this looks very promising. Okay. Good. Then our first goal should be we get it to first we try to implement it so far that we can iterate over the symbols, right? And once we can do this, then we can think about, okay, what do we write? So I do wonder if we where is it? Here. I do wonder if we take any of these ideas as yeah. See, yeah. He did it the same way. PDB, yeah. Okay. Dump PDB. Okay, but does it really need explicit command? Because if we just say dump sims on a PDB file, then we recognize this by the PDB extension of this file, right? So I don't think we explicitly need this. Yeah. Okay, but we take the same concept here. Yeah. Okay, I have a general idea of how to start this. And then we need to figure out like, okay, where do we get the data we need? And what do we collect? I think what we need essentially is the least we need is exactly this, right? The symbols and the sections. Yeah. These things, I don't know if we need this thing here. So we need this. I don't know if we need this here. We need the symbols. And then additionally, what we probably want is, we also want a section where we say, okay, which symbols belong into which compile unit, right? So main.cpp contains this. Yeah. So that we can bundle these together. Yeah. So like, let's say in main CPP was this and this and this, then these three would be bundled into this one unit, and then we would generate files for these things. Yeah. I think this means that we should generate separate config JSONs, because like if we do this mapping from compile unit to functions, then we probably want to load the very same thing for the game.dat generation, right? Because this one is being generated from the PDB, but we use it for both thyme.exe and game.dat, right? Yeah. So we probably want to work with multiple config files in the end to be able to pick up one and another. Yeah. Okay, I have a good idea. It guess will be a little bit of work, but to me it looks doable. Yeah. Good. Good. Then I will take a break now. I'm hungry. It has been 2 hours. It's good time. Then I wish you a great day or night. I hope you learned something from this video, in case you watched. Yeah. Yeah. I think it's possible to achieve what we want to achieve, but it's still a lot of work. Yeah. Good. Then, yeah, I wish you a great day or night. Until next time. Goodbye. Let's make it 2 hours. Oh, we wait a few seconds. Oh. Yeah. So, because if you see, I uploaded 1 hour 59 seconds, and you think, what a garbage. Under 2 hours. What a slacker, you know? But if I upload 2 hours on the mark, then you see like, oh, he did the work. Yeah, 2 hours full is good. Right? He was busy. You know? So let's wait. Let's wait 10 seconds. Yeah, 10 seconds. Go. 5 seconds. Let's go. 2 minutes. Congratulations. Okay, stop.